Hi, anime. I don't know about that. I don't know if ETA Coronae will collapse into a black hole. I'm not sure. I don't know about that one. But I love this question. So, did you know, Drew Crew, my favorite, that neutrinos were considered a dark matter candidate? Were you here during my dark matter candidate live? Guys, are you ready for this? There were three dark matter candidates. They were all sort of what do you call it, dismissed, or some of them are still being researched. But the first dark matter candidate was actually the neutrino. Neutrinos are extremely elusive leptons that are weakly interacting only and also don't interact with electromagnetism. So neutrinos were absolutely very much considered as a candidate for dark matter. But then they were not thought to have enough mass really to account for all of the mass or all of the extra mass that we see in our own galaxy from dark matter. So, good guess. I would say neutrinos are probably a very good guess as to could this be dark matter. But unfortunatamente, neutrinos were not thought to be able to account for all the mass that we see for dark matter. Okay, so probably not, but I love it. Neutrinos are so very elusive indeed. Some of the most elusive, but also very pure cosmic messenger because of that exact reason, because neutrinos don't interact with much on the way to us from some astrophysical source, is why we, for example, picked neutrinos as a cosmic messenger, an astroparticle or astrophysical messenger particle. They interact weakly, but they don't, and they interact gravitationally. They have some mass, but very little. At first, neutrinos, we didn't even know their mass. We thought they could be massless, etc. Lots of mystery with the neutrino. But they do have a little bit of mass. And at this point, when now we think at the current, I believe, I mean, I could be wrong because dark matter is an active area of research. So things could change day to day. But I don't think that neutrinos account for the mass that is missing, which would have to be accounted by dark matter. Okay. But let me tell you about the other. Okay. So did you know that weakly interacting massive particles, WIMP is a dark matter candidate, sort of is inspired by neutrinos. So it's the thought was like, okay, so neutrinos don't do it. So maybe there's, let's imagine or think up a particle, which is kind of like the neutrino, but has more mass. It's kind of like you thought the neutrino might be dark matter. Then you're like, oh, shoot, not enough mass here. So let's think up WIMPs, which is the weakly interacting massive particle. Very much like the neutrino, but more mass. So that is still, I believe, a dark matter candidate. So we will see if the WIMP of some kind ends up being dark matter. Then there's a group of people who also then considered another type of candidate for dark matter, which was called machos, sort of as a opposite to the WIMPs. And this was massive compact halo objects. That's what macho stands for, massive compact halo objects. So then they thought, okay, what if they're not anything too unusual, but just some more massive compact halo objects that are so cold or brown or kind of like a white dwarf, but not white, not luminous, non-luminous massive compact halo objects. Could those be accounting for dark matter? Unfortunately for this one too, if there were such machos, such compact halo objects, we would kind of see them with gravitational lensing, and we don't see enough of them also to account for dark matter. So a lot of these candidates kind of